if V1 is greater than V2, in this case, it will provide you output equal to minus Vsat, right? Wherever your higher output is connected, it will provide you output Vsat followed by the sign of that terminal. Suppose V2 is greater than V1, then it will provide you output equal to plus Vsat. Right? So this way you can compare two signals. Or many times you need to compare a signal with some reference. Okay? So you can connect here a DC voltage source or the source with which you have to compare. So in that case, I may call this as the reference voltage. So V1 will be compared with some constant voltage or reference voltage. So now to this comparator, if I connect the feedback, then I can use it as a Schmitt trigger. So let's see the Schmitt trigger circuit. Yesterday we have drawn a Schmitt trigger circuit. Is it visible? So how is the Schmitt trigger circuit? Have you drawn it yesterday? What is connected at this terminal? Yes. What was the name of that resistor? R-E? R-comp, C-O-M-P. Which resistor you connected, where you have given input? To which terminal you have input? Here or here? Inverting or non-inverting? Inverting. So you have given input through a resistance to which I have labeled R-comp, and here you have connected your input. Okay, this is your V-in. So you have applied input to the inverting terminal and feedback is connected to the non-inverting terminal. You can see output, this is your output and this is input. In between that R is connected. Okay, so let's say this voltage as V1, this voltage as V2. So yesterday I think we had derived equation for output voltage. Have we done expression for output voltage? Is my voice clear? Have we done expression for output voltage? R2 upon R1 plus R2 into plus Vsat or minus Vsat. Okay. Now here I have connected resistance R-comp. What is that R-comp? You know that there is offset problem in op-amp. So in order to compensate that, you can connect there a resistance and its value will be equal to the two resistance we have connected R1 and R2. So R1 parallel to R2, its result, its equivalent resistance is equal to R-comp. So value of R-comp is equal to R1 parallel to R2. Let's see how Schmitt trigger works. In comparator, we have seen that we didn't connect any feedback, right? And the comparator was comparing one input with the other or one input with some fixed voltage. Either you can connect two sinusoidal voltages at two terminals or you can connect one sinusoidal voltage and one DC voltage. So in that case, to that fixed voltage, I may call it as a reference voltage. Okay. So op-amp is comparing one input with the reference voltage, which I have externally connected. Now, instead of connecting here some DC volt, I will take this voltage as my reference voltage. The voltage at terminal 2 or V2 is my reference voltage. Now, what is this voltage equal to? If I ask you what is voltage V2 equal to, so between this point and the next ground, this is the voltage at terminal V2. What is voltage at terminal V2? The voltage between this point and this. Now you see this point and this point are same. So voltage between these two terminals is voltage V2. What is V2? V2 is equal to VR2, voltage across R2. Okay. Now what is VR2? Let's say the current which is flowing through this combination is high, because this is the current flowing and it is getting divided here, here and here, but this current is almost zero. So the same current is flowing here. Okay, so I will write VR2 is equal to I into R2, the current which is flowing multiplied by R2. Clear? What is voltage across R2? The current into value of this resistance, I into R2. Now find out what is I. This is I is the current which is flowing through this voltage divider network R1 and R2. So you can calculate this is equal to VO upon R1 plus R2. This is 0. हा current कसा flow between these two. So voltage at this point minus voltage at this point divided by this resistance plus this resistance. So this is 0 voltage. So I is equal to VO upon R1 plus R2 into R2. Or I will write V2 is equal to R2 upon R1 plus R2 into VO. Okay. This is my reference voltage. V2 is the voltage at this terminal 2. And now I am going to compare this input voltage with this. Okay. In Schmitt trigger, this voltage is getting compared with this voltage. What is V2? V2 is your reference voltage. Now, if you see carefully, our term VO is involved here. Okay, VO is involved here. This VO may have two stages. Either it will be plus VSAT or it will be minus VSAT. Okay, if the voltage at terminal 1 is greater, if this voltage V1 is greater, output will be minus VSAT, and if this voltage is greater, output will be plus VSAT. Why it is changing? Now see, in the previous cases, when we were using here some voltage source, my reference voltage was 6. Okay. Now I am using this voltage V2 as a reference voltage, which actually depends on VO. And VO is changing. It will either become plus VSAT or become minus VSAT depending on which is greater. This is input, sinusoidal input, it is continuously changing. So every time it is taking, whichever is greater, output will switch to either plus VSAT or minus VSAT. So depending on that, I will get two types of reference voltage. One I will call as VUT and another I will call as VLT. Okay, upper threshold and lower threshold. So when VO is plus VSAT, I will call it as VUT, and when VO is equal to minus VSAT, I will call it as, what is upper threshold? V2, its value of V2 when VO is equal to plus VSAT, and what is VLT? It is value of V2 when VO is equal to minus VSAT. So I will write VUT is equal to R2 upon R1 plus R2 into value of VO will be plus VSAT. So I'll write R2 upon R1 plus R2 into VSAT. So this VSAT is plus VSAT. And VAT, lower threshold, is equal to R2 upon R1 plus R2 into minus VSAT. Okay. Clear? Are you getting? Yes or no? Comparator is a combination. Schmitt trigger is a combination of a comparator and a feedback. We are applying feedback to this comparator. Okay. So, comparator always compare two inputs, one with other. So, here one input is a sinusoidal and another input is changing. Okay. Why it is changing? Because it depends. This V2 is second input and this V2 depends on VO, and VO is going to change depending on the input. So either it will be plus VSAT sometime or minus VSAT sometime. So therefore I get two values of V2. One, here VO replaced by first plus VSAT. Second, VO replaced by minus VSAT. So I will accordingly write VUT as R2 upon R1 plus R2 into plus VSAT and VLT equal to R2 upon R1 plus R2 into minus VSAT. Where there is positive sign, I will call it as upper threshold, and where there is negative sign, I will call it as lower threshold. Okay. Now, we define a curve called as hysteresis. Hysteresis. This hysteresis is the difference between VH is equal to VUT minus VLT. Hysteresis voltage is equal to difference between upper threshold and lower threshold. So it is VUT minus VLT. What is my VUT? R2 upon R1 plus R2 into VSAT minus, this is minus R2 upon R1 plus R2 into VSAT. This minus VSAT sign I have taken here. So this is equal to, now what I will do, I will put this, let this ratio R2 upon R1 plus R2 is equal to beta. I will call this as beta. Beta is the ratio of R2 by R1 plus R2, and these resistances, once we design the circuit, the value of this resistances is going to remain constant. So my beta will remain constant. So I will call this as beta. Therefore, let this equation be 2. My equation 2 will become VH is equal to beta times VSAT plus beta times VSAT. 2 beta times VSAT. What I got? VH is equal to 2 times beta into VSAT. Now, what is this hysteresis curve that I will explain you? This part is not. Have we drawn the diagram? I will erase this diagram now. Or I will erase this. We will draw a relation between output, V out, and input. Okay. Before that, let us take here an example. Let VUT is equal to 2 volts and VLT is equal to minus 2 volts. What is VUT and VLT? Beta times VSAT. Let's say it is having some value plus and minus 2 for VUT and VLT. Upper threshold is 2 volts, lower threshold is minus 2 volts. We will design a circuit, then you will come to know how these values are coming. If you design the circuit, you will get some value of R1 and R2. If you put that value of R1 and R2, and if you put the value of VSAT, you will get VUT and VLT. Let's assume that value of VUT and VLT are plus minus 2 volts. I will draw here a different diagram. And the input sinusoidal voltage you have applied is, let's say, 5 volts. This is your V in, it is having maximum 5 volts. And what are your VUT and VLT? VUT is 2 volts, VLT is minus 2 volts. Okay, fixed, constant. Let us mark it. So this will be 2.5, so this will be 2. I am showing VUT and VLT by a dotted line. So this is my VUT, upper means positive, equal to 2 volts. Similarly, I will show VLT. This is my VLT. VLT, which is equal to minus 2 volt. I have drawn the signal and drawn the both reference voltage. In previous case, in comparator, my reference voltage was fixed, means my second input was fixed. If I used to connect here a DC source, it will remain same. But now, I am considering my reference voltage as the voltage at this point. And voltage at this point depends on VO, which is changing, right? So my reference voltage is changing. Okay. So now this is your input. Let's start input from 0 volt. Okay. From 0 volt, your input, sinusoidal input start increasing. This input start increasing. Now this is comparing. Okay. So let's say 0 to 1 volt. It will compare. What is greater? When input is started increasing, it is less than 2 volts. Okay. From 0 to 2 volt, all those points here, they are less than 2 volts. So my input is less than the reference voltage. From 0 to 2 volt, Vin, I am measuring from 0 to 2 volt. Okay. What is greater? Input voltage is less than reference voltage. What is my reference voltage at this case is VUT, upper threshold. Baga, ha point te ha point. So this portion is below this 2 volt. Okay, so input is less. Input is less. So what will be output? Input less hai manje this voltage is greater. So output will be plus Vsat. Comparator output VO काय देणार? Plus Vsat. So from till this point, I will get output equal to plus Vsat. What is value of Vsat? जेवढा VCC असेल त्याचा 90% of VCC, 0.9 into VCC. Okay. So from when your input was less than this reference voltage plus 2 volts, output will plus Vsat because reference voltage is greater. It is connected to positive terminal, so output is plus Vsat. From this point onward, your waveform is increasing from 2 volt to 5 volt. Now what is greater? आता काय greater झालंय? Waveform has exceeded 2 volt. So input is now greater. आता इथून इथपर्यंत input small होता. From this point to this point, value of V in this portion was less than this 2 volt. आता तो about 2 volt गेलाय, right? So input is greater. Means this is greater. So output will switch to minus Vsat. Okay. Output will switch to minus Vsat. लक्षात आलं? It was increasing from 0, but from 0 to 2 volt of input voltage, the 2 volt which was reference voltage is greater, so you got output plus Vsat. Now, above this 2 volt, your input sinusoidal waveform has higher value than this 2 volt. Okay, till what time? Up to here. Okay, so output is switched to minus Vsat. So output is minus Vsat. Now see, जसा output minus Vsat झाला, तर हे voltage काय झालं? Moment your output VO becomes minus Vsat, what is the status of V2? VUT आहे का VLT आहे? It is VUT or VLT. First of all, it was VUT. Okay. Now output here, when it was plus Vsat, output was VUT. But now output is switched to minus Vsat. म्हणजे आता reference voltage काय झालं? Minus VLT, right? Minus VLT, sorry, VLT झालं, means minus Vsat असल्यामुळे it is VLT. So now input is getting compared with VLT. इथे कशाशी compare झालं होतं? VUT. Now moment it has switched to minus Vsat, your reference voltage has become VLT, and therefore input is getting compared with the VLT, lower threshold. Okay. So now it is comparing with lower threshold. Okay. So from this point, it is switch झालाय तुमचा. Here it is switch. Now this value, this value, this value. all this value up to here, it is greater than VLT. VLT किती आहे? -2. And this point, all those points up to here are greater than VLT. Okay. So up to this point, op-amp will remain VLT minus VSAT. Output of op-amp will remain minus VSAT. इथे काय झाले आता? Input has dropped below the reference voltage. Input has dropped below VLT. Okay. Now what is greater than? VLT is greater. आता VLT greater झालं म्हणजे हे reference voltage greater झालं. Therefore output will switch to plus VSAT. या पॉइंटला आउटपुट has switched to plus VSAT. ओके. बघा रेफरन्स व्होल्टेज कसं चेंज होत आहे. कंपॅरेटर मध्ये ते फिक्स्ड होतं. इन केस ऑफ कंपॅरेटर इट वॉज फिक्स्ड. ओके. बिकॉज वी वर यूज टू कनेक्ट अ फिक्स्ड DC source. Okay. But now here your reference voltage is nothing but V2. Means this voltage at this point and the voltage at this point depends on VO, which is changing. So एकदा reference voltage VUT, एकदा reference voltage VLT. Are you getting? Schmitt trigger. The beauty of Schmitt trigger is that your reference voltage is changing. Okay. Fine. So it will switch to plus VSAT. Now compare this point. जसा हा VSAT झाला, now op-amp is comparing your input with VUT. आता तो कशाशी compare करणार आहे? VUT. So this point is, now what is greater? VUT is greater. Okay. कुठपर्यंत greater आहे VUT? All these points up to here, VUT is greater. Okay. So it will remain here plus VSAT. Now here input is becoming greater than VUT. So it will switch to minus VSAT. Moment it switches to minus VSAT, reference voltage becomes VLT. So this way you will get a square wave with on time and off time same. Okay, you will get a square wave with on and off time same. Okay, this is called as symmetrical Schmitt trigger. Let's revise once again. How is the circuit of Schmitt trigger? Inverting Schmitt trigger hai. So where you are giving input? Look at the circuit diagram. Where you are giving input? Which terminal? Positive or negative? Negative terminal. Okay. Through a resistance. Read the value of resistance. What I have written, that resistance name? RCOM. What is value of RCOM? Yes. What is value of RCOM? I told you in the beginning. Yes, correct. R1, RCOM is equal to R1 parallel to R2. हे जे दोन रेजिस्टन्स आपण लावले आहेत R1 and R2, its parallel combination. Find the result of the parallel combination and value of RCOM will be R1 parallel to R2. Okay. What is VUT and VLT? What is VUT and what is VLT? Yes, Vijay. Upper threshold and lower threshold. Can you tell me expression for VUT and VLT? R1 or R2? What is VUT equal to VLT equal to? You have written the derivation, no? VUT equal to?
R2 upon R1 plus R2 into plus VSAT.
Correct. R2 upon R1 plus R2 into plus VSAT. And VLT, R2 upon R1 plus R2 into minus VSAT. Okay. This VUT and VLT is nothing but the voltage across R2. And it is nothing but voltage V2. Clear? Is nothing but voltage V2, and this V2 is our reference voltage. We are comparing our input voltage with the reference voltage. Okay? And the beauty of Schmitt trigger is that your reference voltage is changing every time. Every time your output switches to plus VSAT, reference voltage changes. When it changes to minus Vset, again reference voltage changing. So remember, reference voltage is not constant, but it is changing. Okay. Therefore, if when you want to draw the waveform, draw a sinusoidal signal, draw your reference voltages also, that is VUT and VLT. Okay, and find when the input is greater or less. Input is connected to inverting terminal. So whenever input is less than the reference voltage, you will get output equal to, when input is less, you will get output equal to plus Vsat. When input is greater, you will get output equal to minus Vsat. When output switches, your reference voltage also switches. Therefore, when you come here, after switching, compare your input signal with VLT. When you are here, compare your input signal with VUT. Okay, you have to make a practice of drawing this two waveforms. Okay, now let's understand what is a hysteresis curve. Let's understand what is a hysteresis curve. So I'll erase this. Let's draw important. On this axis I draw output voltage, on this axis I draw input voltage. Let's see how your output is changing when input is changing. So the changes in the input is reflected on x-axis, and y will be the changes in the output will be reflected on y-axis. Now your input voltage is varying, and I have to compare with the two thresholds, VUT and VLT. So I will draw my VUT and VLT over here. So let's say this is my VUT and this is VLT. Remember here, magnitude of VUT and VLT are same. Okay, because in the next derivation we will see asymmetrical Schmitt trigger. In asymmetrical Schmitt trigger, you can have different values of thresholds. In symmetrical Schmitt trigger, the value of thresholds are same. Only one is positive, another is negative. Okay, but their magnitudes are same. We can change the magnitude, but we will call that circuit as a asymmetrical one. This is input. When input is less than VUT, means this portion. When input is less than VUT, what is output? Plus Vsat. Okay. So during this, before all the values, this is V in, we are showing on this axis V in, this is VUT. So all the values, for all the values before VUT, your output will be plus Vsat. Okay. So I will draw here, plus Vsat. Plus Vsat. This output will be plus Vsat. When your input voltage try to become greater than VUT, input voltage has exceeded the threshold for this portion. What is output? What is output for this? Minus Vsat. Okay. So what will happen? Moment it starts exceeding exactly at VUT, output will switch to minus Vsat. See how I have drawn. Before, when I was increasing input, but its value was less than VUT, I was getting output equal to plus Vsat. Moment this Vin has tried to exceed exactly here, the output switches and it becomes minus Vsat. So this is my minus Vsat. This is minus Vsat. Okay. So for all the values which are greater than VUT, output, no. Now I have to make my comparison with VLT. Once the state has changed, I will compare with VLT. So moment all these are greater than VLT, because this is negative direction. So it will remain minus VSAT. At VLT, again it will switch to plus VSAT. It will change the direction. And it will remain to plus VSAT. This is called as hysteresis curve. So hysteresis voltage is this. From this point to this point, VUT minus VLT is equal to we have already derived this, so I will directly write 2 times beta into VSAT, or this is your VH. So this plus this minus this equal to the 2 times beta. So double of this is your width of hysteresis. VH is equal to VUT minus VLT. So how to draw hysteresis curve? When input voltage is less than VUT, output is plus VSAT. At input voltage is equal to threshold voltage, upper threshold voltage, output switches and it goes towards minus VSAT. Okay, then it starts comparing with VLT. So output remains minus VSAT till it crosses VLT, and at VLT again it becomes plus VSAT. So that's why such type of loop is drawn here, which is called as hysteresis curve. Okay, which is called as hysteresis curve. Now take one problem. Let's design one Schmitt trigger, and then we will have another Schmitt trigger. Design symmetric Schmitt trigger. Take a problem. Everybody note down the problem. All online students note down the problem. Design symmetric Schmitt trigger circuit. Everybody please wear a mask and please take proper precaution. Don't do a smaller mistake even. Is anybody's family has suffered from corona? Anybody from you? Okay, so that's why you are wearing mask. Everybody please understand, don't take it lightly. Okay, I have gone through that all phases, so please be careful and take precautions. Okay, design symmetric Schmitt trigger if VUT equal to 2 volts, same we will take, VUT equal to 2 volts and VLT equal to minus 2 volts. Draw the output waveform when plus 10 volt peak to peak voltage plus 10 volt peak to peak sine wave voltage is applied. So first of all, you draw a Schmitt trigger circuit. I'll repeat the problem. Design a symmetric Schmitt trigger circuit if VLT equal to plus 2 volt and VUT equal to plus 2 volt and VLT equal to minus 2 volt. Draw the output waveform when plus 10 volt peak to peak input sinusoidal waveform is applied. The supply voltage to the op-amp is plus minus 12 volt. Supply voltage to op-amp is plus minus 10 volts. So what is given in the problem? VUT 2 volt, VLT 2 volt, Supply voltage VCC equal to plus 12 volt, VEE is equal to minus 12 volt. What more is given? Input Vin is equal to 10 volt, 10 volt peak to peak. I told you what is peak and what is peak to peak. Is it 10 volt? Okay. Let's draw the thing. So this is your Schmitt trigger circuit. It's already there. Always remember, design, the word design means to find out the value of each and every component present in the circuit. Design means find out the value of all components present in the circuit, which will provide you the indicated specification, indicated result. Okay, so we have to design this circuit. Now, what is VUT and VLT? Tell me again. VUT, where it is? Can you locate? Can you tell me where is VUT? Is this? Yes or no? Is the voltage at this point is called as VUT or VLT? Yes or no? Speak loudly, please. Yes or no? Yes, Tejas. Don't know? What is the voltage at this point? V2. This point is nothing but this point. Connected. This voltage is nothing but V2. V2 is nothing but the voltage across R2. It is nothing but a reference voltage. V2 is a reference voltage. V2 is nothing but reference voltage. V2 is nothing but VUT and VLT. Because you have found it. What is V2? It is VR2. What is VR2? I into R2. What is I? VO upon R1 plus R2. So VO upon R1 plus R2 into R2 is the voltage. VO is present here, which is going to change either to plus Vsat or to minus Vsat. Let's design the circuit. What is given? So what is VUT? If you don't remember this is voltage at this point, and it is equal to, just now we have derived R2 upon R1 plus R2 into plus Vsat. How to find Vsat? Vsat is equal to 0.9 into VCC. Okay. So 0.9 into, what is VCC given to you? 12 volts. Find how much it is. 90% of VCC. How much? 10.8 volt. Everybody should have calculators with you. 10.8 volt. 10.8 volt. Your VUT is equal to beta times plus Vsat, where your beta is nothing but R2 upon R1 plus R2 into plus Vsat. Okay. So I will write how much is VUT? It is 2 volts. This ratio I don't know. Okay. And Vsat is 10.8 volt. From this, can you find beta? Therefore, beta is equal to 2 upon 10.8. Calculate. So therefore, you get ratio R2 upon R1 plus R2 equal to 2 upon 10.8 equal to, calculate.
0.185.
Speak loudly, please. 0.185,
0.185.
correct. 0.185. 0.185. Now, whenever it's a design problem and you have to simultaneously find two resistances, then you can assume one and find another. Okay, you can assume one and find another. For example, in this case, let us assume R2 equal to 10 kilo ohm. Okay, right? Assume R2 equal to 10 kilo ohm. You can assume any of the resistance. Preferably R2 is present here two times. If I make assumption for R2, the further things will become easier. So let R2 equal to 10 kilo ohm. Okay, now put this value. Therefore, 10k upon R1 plus 10k is equal to 0.185. Therefore, find R1. Find R1 from this. How much does R1 come? 10 k is 10 into 10 raised to 3. Okay? Or even if you don't convert it, you will get the answer of R1 in K. How much R1 is coming? What's the value of R1? Yes, anybody calculated? Online students?
4.05.
Yes. Repeat again.
4.05.
44.05 into 10 raised to 3. किलो मध्ये आले ना? 44? Are you getting 44?
Yes, ma'am.
Okay. So R1 you are getting 44. So see, first resistance you have assumed R2, second you have calculated. So you can write this values here. R1 equal to 10 kilo ohm here and R2 comes to 44 kilo ohm. Okay. Now you have to find RCOM. What is RCOM? RCOM is equal to R1 parallel to R2. That is 10k parallel to 44k. Remember, whenever you are solving any parallel combination, whatever is the smallest resistance, suppose one is 1 ohm, another is 100 kilo ohm, and another is 10 mega ohm. So whichever is the smallest, you will get the result lesser than that smallest value. So definitely you will get result lesser than 10k. So find R1 R2 upon R1 plus R2. R1 R2 upon R1 plus R2. That is equal to 10 into 44 upon 10 plus 44. So how much you are getting?
8
How much?
point one four.
8.14.
Yes.
How much you are getting? 8.14 kilo ohm. Okay. So write this value. You can assume the standard value 8.2k. Okay. Assume standard value 8.2k. Now you have to draw the waveform. So everybody, all the online students, please draw this waveform. I am going to continue the lecture after 15 minutes. So show me this waveform. In the next lecture, we'll